Hey robot makers, hope you're having a good day so far. So do you want to know how to make your own DIY ChatGPT? I promise it's exactly the same. Using Python and understanding how language models work, then this is the show for you. So let's dive straight in. My name is Kevin. Come with me as we build robots, bring them to life with code and have a whole load of fun along the way. Okay, let's get over to our ChatGPT DIY project using Python. So we're going to have a look at how language models work today. They're really fun, and this is something you can do yourself at home, which is quite fun to do. So we're going to look at what language models are. We're going to have a look at Markov chains, what they are. We're going to build our own language model using Python, and then we're going to create a quick web UI using Flask so that we can have that sort of same experience of ChatGPT. We'll even have a play with ChatGPT-4 as well if you want. We'll have plenty of demos of that code throughout, and if you're watching this live, I'll also have a bit of a Q&A mailbox or what have you at the end. Okay, so let's get over to the next bit. So what are language models? So language models are a type of artificial intelligence algorithm designed to generate and understand human-like text. I love the way they say human-like, as if there is other varieties now. Well, I guess there is with ChatGPT-4. There is now language that comes from non-people. So the goal is to predict the likelihood of a sequence of words or generate text based on a context and previous knowledge. So generate text based on context and previous knowledge. And we can train language models. We can use machine learning to pass massive data sets of text from various different sources. The architecture can be based on deep learning techniques. Ours is going to be quite basic, to be honest. We're going to use these Markov chains. And you can use things such as these recurrent neural networks, RNNs, long short-term memory, or LSTM networks, and transformers such as GPT and BERT. We'll have a look what GPT is all about in a second as well. And applications of this, so obviously we can have, I'll just turn that down a second. We can have text generation, we can have translation, we can have summarization, which is pretty cool. You can get a big block of text and have the thing summarize it for you. Sentiment analysis, that was some of the first stuff I looked at with Twitter back in the day. You could see what the sentiment is, say, grab 1,000 tweets and analyze them for certain words and see what kind of emotions people were describing there, and therefore what kind of sentiment was being described or expressed against a particular person or thing. Chatbots as well, voice assistants. So I'm very keen on looking at how I can implement this, or possibly even a ChatGPT API call for my own Python assistant longer term. So that's something I'm interested in. And then some of the challenges. This is really interesting. So if you're bringing in loads of different text from different sources, where has that text come from? Who are the people who've authored that text, and what are their biases? Because you're going to build that into your model. So you need to be really conscious and mindful about how you treat bias in your training data. There's ethical concerns as well. So one of the first things I did on ChatGPT was say, how would you get rid of a dead body? I was really keen to see how it would handle such an ethical type question, and it came back immediately and said, this is not a question you should be asking. It's unethical for a single person to dispose of a body. In most cultures it requires at least 2 or more people to dispose of a body. I thought, I didn't know that. I've learned something new, and also feel a bit guilty from an AI telling me I shouldn't ask such questions. Not a psychopath. So yes, ethical concerns. Computational resources, they do require a lot of memory for the very large data sets, depending on the model that you're using. And there's also limitations of understanding of context and real-world knowledge. So for example, ChatGPT 3.5 can only understand things up to the year 2021. So anything that's happened between then and now, it doesn't know about, and therefore can't access that. I think ChatGPT-4 will have a near real-time access to some data, though that's still a work in progress as I understand it. So what is GPT? You hear this term quite a bit. So it stands for Generative Pre-trained Transformer, and that's the type of language model that's been developed by OpenAI, the group who've developed ChatGPT. So yes, it's based on one of these very advanced deep learning, and it's actually several layers of technology, of algorithms. It's not just one particular algorithm, it's a whole suite of them plugged together to do some really clever stuff. So the transform architecture, GPT levers this self-attention mechanisms, allowing it to efficiently process and relate different parts of an input sequence, which improve the context. So we can't do that in our model. Ours is very, very basic, but that's something that transform ones do. Pre-trained means that it's there's a large volume of text. So I understand they put in things like Wikipedia, the entire source of Wikipedia. I think there's some other sources. I'm not sure. I think it's things like what's the name of that? Is it Stack Overflow? GitHub. There's quite a few different sources of very large amounts of information that they put in, as well as like the Gutenberg Press, which is where I got a few of the books that we're going to be looking at today. So let me just turn that down a bit more as well. Can you see that little thing on the screen? That's quite cool. And what else have we got? So yeah, pre-training it means that we basically do all the processing, building that model first, and then we just use that model to generate text from. The fine-tuning that they do with the GPT helps with things very like specific tasks like translation, summarization, question answering, and they are better achieved by adapted to certain domains. So that means if a user asks a particular type of question, they might use a slightly different model than the main model, for example. The generative model, so GPT is designed to generate human-like text by predicting the next word in a sequence. That's what our thing will do today. It's really cool, a bit unnerving, a bit uncanny valley, but it's really down to the person reading it to understand how it works. But what I want to do today is show you how this works so that you can understand how something like ChatGPT actually works behind the scenes, and it's something that you can understand. So scalability-wise, ChatGPT's architecture scales very well with increasing model size and computational power, leading to these improved performance and performance of data and resources utilized. So ChatGPT-2, ChatGPT-3, they've been tuned for efficiency and scale. ChatGPT-4 currently has quite a lot of computational cap on there because they're still building it out, and I think the algorithm's a bit more resource intensive as well. So GPT has been applied for various different natural language processing applications such as chatbots, text summarization, translation, sentiment analysis, and more, like we've mentioned before. So stochastic models and what they do. So stochastic models are a mathematical representation of systems and processes that incorporate randomness or the probability to predict or describe the evolution of an outcome over time. So that's a really in-depth way of saying, I should have run this through ChatGPT and had it summarize it for me. When you change from one state to another, and when we say state, if we're generating text, if I say the word the, there are a finite number of words that will come after the word the. That not every word will come after that. So for example, the word the probably wouldn't follow the. You wouldn't have the. It's unlikely. So you can actually map in a table the probability of any one given word following another word. So that means if a piece of text, a user inputs a word, you can predict what's likely to come after that, and then you can then move that window along and then say, based on that word and the word before it, what's going to happen after that, and then so on. And you can generate your text using these stochastic models. So you can see there the state changes from A to B, B to C, C to A, and the probability of moving between those two states. You've got that probability of A, comma B in there. And you can then basically run this model for all the different words that you come across in a text. So I'll show you how this happens in our language model shortly. So a Markov chain is a type of GPT, and it's a type of stochastic model, I should say, representing a sequence of events or states where the probability of each depends on the previous state, only the previous state, and not all the words before it. So it's just kind of like, we'll look at the current word and the word that came before it, and that's all we do. So this means that we have this memorylessness state, and then this is a key property or a Markov property, which states that the future state depends solely on the current state and not the entire history. So that means we can get a word or two, and we can look and guess what we think the next one will be without having to understand every word that's ever come before that, just the one that we're looking at currently. There's also a thing that we looked at before, that little table, that's called a transition matrix, and that represents all the probabilities of transitioning from one state to another in a chain. And a stationary distribution is a probability distribution that remains unchanged. So sometimes you want things to stay the same in a Markov chain, and that's a property you can train for and test for. And applications of this, we can do text generation, which is what we're going to do. We can do speech recognition. We can do economic prediction, weather prediction, genetics, and other fields of sequential data where we want to try and guess what the outcome will be of the next in sequence. So limitations of this approach is the lack of long-term memory, the inability to capture complex relationships or dependencies beyond the immediate and previous state. So we're going to use them today because they're very simple to understand conceptually and implement as well. So this is how we're going to do this today. We are going to get a corpus of text. We're going to use War of the Worlds by H.G. Wells. We're going to get the complete works of Shakespeare. And there's also a whole bunch of other books that I've downloaded from the Gutenberg project, which allows you to download any work of any text work for free because it's gone out of copyright and they've kept it down this website. You can just download it as an ebook or plain text and so on. We're then going to write a piece of code that will build a language model as a JSON file, just somewhere to store it. Again, this is probably not the most efficient way of storing this data, but it's the simplest, so we've gone with that. And then we're going to generate text from that language model with a little text generator piece of code. And then finally, we're going to wrap this in a little web user interface so it looks a little bit like ChatGPT. So this is what we're going to do. This is our approach. So let's have a demo about how we actually build this model, shall we? So I'm going to get over to Visual Studio. Here's one I prepared earlier. So the first thing I want to show you is, let's just get up the War of the Worlds text. So this is what the text looks like. This is going to be what we're going to generate some of our language model from. So you can see in there, we've got all different kinds of text in there. It's got a particular style of talking in there. Yet so vain is man, so blindly, and so blindly in his I can't read while I'm sort of live streaming at the same time. So blinded by his vanity that no writer up to the very end of the 19th century expressed any idea that with intelligent life might have been developed there far. So this text is written by H.G. Wells. I can't remember when that was, does it say at the beginning then? It's sort of 20th century, I think, early 20th century, I'm guessing. Where's the published date of that? You'd have thought they would have that on there. Anyway, so that's one of the texts that we're going to use. I've got some other ones as well. So I've got this the Expedition of Humphrey Clinker. We have the Enchanted April. These were like the top 20 books from the Project Gutenberg. We have The Adventures of Ferdinand Count Fathom. We have Moby Dick from Herman Melville. We have Middlemarch by George Eliot. We've got Little Women by Louisa Alcott. And what else we got? The complete works of Shakespeare, which is quite a small file, surprisingly, given it's his complete works. But yeah, they're all the works that are in there. So again, the language in this is very Oldie English. So if we use just that, our model would only be able to speak Oldie English. So that's interesting. We've also got the Blue Castle there. We have A Room with a View. And I think that's it. They're all the different ones I can choose. But we'll start out with just War of the Worlds. It's reasonably recent English as far as classical works go. And we can build our model from there. Right. So what we're going to do is we're going to use this code over here, build model. So this has got a function that's called build language model. It's going to take in a file name, and if we provide it a model, it will use that model. Otherwise, it will just create a list dictionary. I think that is, sorry. Yeah, squiggly brackets is dictionary. So it's going to open up the text file, and it's going to read in all the text into a variable that's called text. We're then going to split those words just using the text split, so that we end up with a dictionary of words, and then we're going to change all those words using this dictionary comprehension here, and that's basically just going to turn all the words to lowercase. It just makes it easier to model. We end up with a smaller model, and it's probably slightly more accurate. And then this is the bit that does the work. So we're going to say for I in the range of the length of words -1. So for all the words that we have in our little dictionary there, we're going to say word, the current word we want to look at is going to equal whatever the current loop is, so I plus 1. If word is not in the model, then we're going to say model word equals nothing. And then if the word is in there, so if the next word is not in the model, we're going to do the same thing, next word equals 0. Otherwise, we're going to say model word, next word plus equals 1. So that's going to essentially just put the number of times that word's been used. We're going to update that, and we're going to add the word to our model. So we're going to end up with a word, and then we're going to have like a little dictionary of other words that come after that and how frequently that happens. That's the simple how we build our model. We can have a look at the output of that, and it might make a little bit more sense. I then got save model, so it'll simply just save out the model that we provided to a particular file name, so it just does a json.dump. And then we've also got another function there for loading the model from a file, and it just does the opposite there, it just says model equals json.load. So that's how we build the actual model from a text file. So what we're going to do here, I've got two variables and I can just uncomment one. So we're going to start out with waroftheworlds.txt is our file name, and then we're going to say the model file name that we're going to end up creating. This is going to be called language model.json. We're going to start out with a blank model by saying model equals nothing, an empty list or empty dictionary. And then we say for file in files, because we might have more than one file in here. If we've only got one, then it's just going to go around this loop once. And model equals build language model, pass in the file that we're currently using in the loop and the model as it is. So if the model starts out blank, then we're going to pass in a blank model. If there's several files in our list, then it'll pass in the model as it's been built, and it'll build up that model. So by the time this loop's finished, we've got a variable that's called model that's huge, that's got all this kind of information inside. And then we can save that out by basically just doing save language model, the model that we've just created and the model file name. We can load that back in just to make sure that we can do this, and then we can print it out. So what I'm going to do, I'm going to run this now, and we've just got waroftheworlds.txt. So let's just run this, and it's going to print out there. You can see we have, say, for example, the word thus, and that's occurred once, and then the word thus and we, and PG and search, all these different things come after that word, and the number of times that they have occurred after that word is represented by that number 1, for example. So that is our model that we've created. So what I'll do now, I'll just go and see how big that file is. We don't have the file sizes in Visual Studio, so let me just bring up that that folder. So I think it's in Python, and where are we? Is it in that folder there? I think it is. ChatGPT. There we go, MicroPython. And where are we? So I'm just trying to find the right folder here. So it's under MicroPython. There it is, GPT chat. Right, so if I come over here, we can see now that that language model is only 645k, so it's quite small. And that's the one that we've just looked at, which is all those different words there, for example. Now, if we build this out to be a larger one, so if I uncomment that and comment that out, so we're going to read in the complete works of Shakespeare and all those other books I talked about before. I'm going to run that, and it only takes 5 seconds to build out that new model. So there we go, just 5 seconds. So it's quite quick to build because this is actually a very simplistic model. I said 5 seconds, it's now taken a little bit longer because my machine's doing some other stuff. There we go. Right, so if I now go back to that Finder, and we have a look at the size now, it's 14.7 meg now, so that's significantly larger than the 645k that we had. But potentially we could make a model if we optimize how we store it, and the number of books, the number of the corpus text size that we put in there, we could potentially get it to run on a Raspberry Pi Pico. That's one of the things I'd like to be able to do. But so far this is just running on a regular computer, on a Mac. So we'll rerun that just with the War of the Worlds one, just because I want to show you what the model will look like. So there we go, that's really quick to do. And we've just updated our language model.json there as well. So if I look at that, it's 645k again, and that's the size of the file. If I just scroll down, you can see there's a lot of words in there. There's some of them that have got a number higher than 1. So there's the word from has got 4 there. Into has got 6. So common words, as you would expect, have a higher number of occurrences. So that's the first part I wanted to show you. Let me see if there's anything else. Nope, that's all good. So let's get back to our keynote. So we're going to run the text generator next, and we're going to have a play with how this actually works. This is so fun, right? So let me get back over to Visual Studio, and I can't remember why this has now been lost in the midst of time. I call this one pickle test. I can't remember why pickle. There must have been a reason for that, but it ended up like every time I adjusted it, I basically renamed the file pickle 13. But this is the version that works really well with this particular piece of code. So we're going to load in the language model as we've done before, and then we've got this generate text. So this is going to take in the model. It's going to take in what it calls a seed. So that's what you type into like ChatGPT. And then we're going to say how many words do we want it to generate in that sequence. So that's the length. So before we do that, let's go over to ChatGPT itself and let's see how that actually works. So let me go over to ChatGPT, which is here, just in case you've never seen this. And I'm on ChatGPT 4 here. You can choose which version you want to use. And you simply just type in something that you want to know. So if you've got any suggestions of things that I should type in, let me know in the chat, and I will give that a go. So I'm watching the live chat and seeing if anybody suggests anything. And while you're thinking about that, I'm going to type in something here. So I could say, write me a blog article about ChatGPT and how it works. And then you could say in the style of, or stuff like that. But let's just press enter and let me show you how this works. So it says title ChatGPT, subtitle a deeper look into ChatGPT and how it works and what makes it special. So it's going to basically just generate text. This looks magical. And this is revolutionary, how this actually works. If you think of all the different industries where people have to write things for a living, they have to generate ideas, this is really, really useful for helping you do that. I'm not saying it could do everything, although it probably could, but you probably want to check through it because of the reasons we've said before, like the biases. We want to know what else? Any ethical concerns that it might have in there. So is it suggesting people should do things that are unethical? And so on. So you wouldn't want to just leave this unedited and unchecked. You'd want to check through that it works fine. It's interesting how there's a speed to this. I understand that isn't just so it looks interesting like a typewriter. I think that's actually to do with how fast the algorithm can actually work. So I'll just let that one finish. We can actually say stop generating, and it also has a built-in number of characters, number of words it will generate itself. It has like a limit. So sometimes you'll see it do this and it'll just stop mid-word or after a word. Now, the way that they've generated this, when I would do my tokenization, you can choose how large you want that token to be. Because what we created in our code earlier is called a tokenizer. We can either do it based on a word, which is what I've done, or you could do it on like letters. You could just say 2 letters or even a single letter, but you end up with a lot more garbage. So just choosing words is better. Now, what they might have done with ChatGPT is have 2 words as 1 token, and that makes it more likely that you're going to get better grammar. So there we go. It's finished doing that now. And I can now ask it questions. This is where the reasoning part of ChatGPT is quite mind-blowing. So I can say, criticize. If I type it incorrectly, the text above, and tell me why it's bad. Can't type. Tell me why it's bad, and then use that advice to rewrite it. Okay. So it's going to consider the text that it's just generated. Remember, there's no consciousness here. This is just machine learning and text generation. So it's criticizing it. So the introduction could be better to capture the reader's attention. The explanation of the transformer architecture is vague and could be clearer, and so on. So it's now rewriting it based on the things that it knows is wrong with it. So it's going to make it much more punchy. So I find sometimes once you've generated it, get it to criticize it and rewrite it with that better advice, and you end up with a much better piece of text. So I'm going to stop it generating there, but you get the idea. This is how it works, and you can ask it literally anything. So somebody said, tell me about Kevin McAleer. Now, previous to 2000, 21, I didn't really have any presence on the internet that was worthy of any kind of attention like this. So what's likely going to happen here when I press return is it's going to tell you about the Irish comedian who is also called Kevin McAleer. I think he wrote... there you go. So based on its knowledge of September 21, Kevin McAleer is an Irish comedian known for his deep pan style and unique observational humour, and so on. I think he did some stuff with Father Ted, which is like a TV show in the UK or in Ireland. So there you go. So it's basically, it's pulling information from things like Wikipedia. So I've actually downloaded the entirety of Wikipedia. It's about 6.5 gig compressed, and I can run that same text from Wikipedia, and it might take it more than 5 seconds to do this. It might take quite a bit of RAM, but we can basically run that through the entirety of Wikipedia, and then you will start to embody some of that knowledge, and just in the sequences of words that are generated. That's what's quite clever. Okay, so let's get back to our Visual Studio. So what we're going to do, we're going to read in some words from the user. So the word's going to give a sentence that we want to search for. We are then going to give it a length that we want to generate. So how many words we want to generate. And then what this is then going to do is it's going to say seed word equals seed lower split. So that's going to split up the words into a dictionary and make sure they're all lowercase, because that's how a model is formed. We're then going to say the key equals seed word minus 1. And if the key is not in the model, then we're basically going to return, we're basically going to say no entry or something like that. Okay. What else? So then the output equals, we're going to join together the seed words. So we're basically going to initialize that. And then this is the bit that does the work. So for I in range length of the seed words, we are going to say next word equals random choices, and then list of the model keys, list model key values. So a model, remember, is a dictionary of key value pairs, and it's going to look through the possible sequences of words that could happen next, and it's going to pick one randomly. So this is one of the crudenesses of our model. We could use something far more sophisticated there, where it looks like the highest probability word rather than just choosing it randomly. But the randomness does mean that we get an interesting response each time. We don't get the same response every single time if we enter the same piece of text. And then we output is equal to the next word plus space, and then that plus equals means it's just going to add it to the output. So output equals output plus next word plus a space, and the key equals next word. And then it's going to return the output. That's all that we need to generate our text from our model. It's very, very simple. So the rest of the program, it's going to take in that file name, language model.json, that thing that we just built. It's going to take the seed from an input response from the user, and it's also going to take in a length, which is an integer. It's then going to load the model using that model file name. It's going to generate some text that's going to store in text, and then it's going to print it out. So let's run this and see how it does. So we're going to enter some seed text. So I'm going to say tell, oops, let me do that down there. So I say tell me a story. Let's see what happens. We want it to generate, say, 100 pieces of text. And there we go. Tell me a story became belligerent, and the first meant or a Dutch doll is my younger sister of the house. So it's a bit nonsensical, but what it does mean, let me just go to that screen for a second. I just want to mute. I thought I'd put that on do not disturb, but it doesn't seem to do that. There we go. Right, let's go back to there. There we go. So there we go. We've got a block of text that's been generated, and it's only been generated on this particular one from the contents of the book War of the Worlds. So you'll see it talk about space, about death rays and stuff like that. So let's run this again and see if we type in death, and then let's generate let's say 20. Death on a summit, towering high and so long, and for the tremendous tragedy of a little two-wheeled cart. So it's kind of nonsense, but it seems to make sense. There's because of the way that the model's been constructed, the grammar has kind of been built into this. So, and so long, that sequence of words is a sequence that makes sense in English. So we've actually embedded within our model grammar, which is quite cool. Things like and for, you wouldn't normally have that after a full stop. So there are some quirks, obviously, with this model. So let's try going back to our build model, and then let's use that much larger corpus of text. So I'm just going to regenerate our model because we only did it off that War of the Worlds the first time. So let's rerun this again. It'll just take a couple of seconds for it to do that. And then we'll get over to our pickle test 2, and then we'll rerun it again. So let's wait for it to finish that. There we go. So let's now rerun it with our much larger. So I'm going to say, tell me a story, which is what we did before. And then let's generate 200 lines of text. And then let's just see what it's come up with. So tell me a story as wedding cake. Amelia fitted forth, enter George whispered, is this work me a story as wedding... Well, I've jumped the line there. Is this work forever? I gone he would besides. So again, it's a bit more nonsensical, but it's weird how this actually works, that we have, I think he could put the, I don't know how you pronounce that, Stochastic flavour. The way that it's embedded and understand grammar and the sequence of words, it's quite weird to see this come back. So that's how we can build from a reasonably small corpus of text a language model that we can then use to generate some text. So that's the next bit. Let's go back to here. So what we're going to do next then is build a Flask Web UI. So this is going to enable us, Flask is a Python framework for developing web interfaces and APIs. So we're going to create a really simple one so that we can have a kind of ChatGPT interface on there. So we need a couple of things for this. We've got our language model. We just need to put our text generation, loading and saving stuff into a class, and then we're going to call that class DIY ChatGPT. And then we need to create a webui.py, which is basically just going to be a very simple Flask program, and an index.html, which kind of just lays out the page, like the text field and the reply piece. So let's do that. And yeah, this is basically what we're going to put in there. So import Flask, Flask render template and request. They're all the bits and pieces that we need to create the web page. So Flask is the model for generating web pages. Render template can take in a index.html, and if you put a variable name in there, it can replace that variable name with the contents of the variable. And then request just handles the sort of posting and getting of requests from a user from an endpoint which we'll create. We're then going to load in our ChatGPT model. We'll have a look at that in a second. And then we're going to create an app that's called Flask _name. And then the chatbot will become equal to the ChatGPT class that we're going to create as well. And then this app root, that's a decorator, app.root, and it's going to look for anything that's passed to the web server, either using get or post requests. And then if it gets that, it's going to run this piece of code. So it's going to say response equals nothing. If the request method is post, so the user has posted a request to the web server, then we're going to capture that input, a user input into that user input variable. And we're going to say request .form user input. So there's going to be a user input name on our form, and we're going to get the contents of that and put that into that user input variable. And then the response is going to become equal to, this is the thing we send back, the chatbot.generate text user input and then 100. So the user input is that seed, and the 100 is how many characters, how many words we want to generate using our chatbot that we've just created. And then we're going to print to the console as well just what the user input was, just to help us debug this. We're then going to return the rendered template, which is index.html, and we're going to pass that response as a variable to response, which is within our template. We can have a look at that too. And then we're basically then just going to say keep running the app. So it's just going to keep running until we do Command and C. So it's as simple as that. All right, let's have a look at this in Visual Studio. Let's see how we can get on with this. So let's look at the index.html first. So if you've never looked at HTML before, this is kind of how it works. We can get rid of all that style stuff. Actually, that's not needed anymore. And yeah, this is HTML. So you always start out with a HTML tag, and you have matching pairs of tags. So when you start a tag, so the word head, you have a /head to end it, and then everything within it is considered to be within that tag. So you've got meta tags that tell you what the page text formatting is, UTF-8. We've got links to two things. So there's something here that's called Bootstrap, Bootstrap is like a really nice framework for doing CSS for you. So it means you can have really nice stylized web pages without having to figure out all the complicated stuff behind the scenes. So this is the web page itself. It's actually quite small. So we're going to have a light background. We're going to make it 100% of the screen, and we're going to have no margins or padding on there. So that's what the M0 and P0 mean. We're then going to have a heading 1 style that's text centered. So it's going to be in the middle of the screen, and it's going to say DIY ChatGPT. And then we're going to close that tag. And then we're going to have a container. So this container, if I click on that div, you can see that that div down there is the sort of matching one. So this is like a container on the screen, and it basically just puts it centered in the screen and with a bit of margin either side. We're then going to have an output area. So on the very bottom of the fixed bottom, we're going to say is the output, and that's where the response is going to go. And then we're going to have another area here. So this is the white bit. This is where we're going to have our variable, which is, so this is where we're going to have the form where we type in what we want. So that thing there where it says response and these 2 squiggly brackets, that is Ginger 2. That's a way of passing in a variable into a web page, and when we do render template, it's going to replace the contents of that block there with whatever we pass in, which is our generated text. So that's what's going to happen here. We've got other things in, like we've got 2 columns in a row. We've got a form control, which is a user input, and it says type your message. And we've got a button that's just submit, which just sends that to the user, to the background. Okay, so that's the index. We've got this DIY ChatGPT class. So all I've done here, all that code that we just wrote before, this just encapsulates it into a single package. So class DIY ChatGPT has got a build language model. It's got a save and load language model, and it's also got an initialization. So it basically just looks at that language.json file, creates a blank model, and it's set to begin with the file waroftheworlds.txt, just in case we wanted to load that. And then it'll load in that model. We've then got generate text, which does exactly what we wanted it to. It's exactly the same as the one that we've just looked at in the pickle test 2, but this is now all inside one single class. So if we come over now to our web UI, we can do this chatbot equals ChatGPT. So we can say chatbot.generateText or chat.model if you want to access the model, or chatbot.loadModel or chatbot.saveModel, and all those things will work as we expect. So let's give this a go. We're going to run this. And what we get on the terminal down here is we get, so it says serving the Flask application web UI. Debug mode is on, and it says this is a development server, do not use this in production. And the reason for that is it will give you error messages that are helpful for you as a developer, and you don't want them to be seen by users in the live environment. And then it's given us an IP address there and a port number 5000, and that means that we can actually access that. If I just jump over to chat, and let me just load this up. So that was 5000. Let me go back over to there. And here we go. So DIY ChatGPT, type in your message. So if you can see there, tell me a story. And if we send that, it's generated a block of text. It doesn't do the sort of thing because it's instantaneous, because it's such a small corpus of text. But you can see there, tell me a story from the sack of a human being. The giant and furze bushes to them scared and went to death. Again, a lot of this is the War of the Worlds text, so you'll see a lot of that stuff in there. But yeah, you can ask it different things, like I did the word dog. Let's try that. Dog cart. That must be embedded within the text that we've... because if you type something that it doesn't recognize, if I say hello, it doesn't return anything. It doesn't have that in its corpus, in its language model. If we type in where are they, for example, it doesn't know that. It does know live stream, which is weird. So a live stream of having it and standing at the Waltons across him. There we go. What else have we got? Where is it? Let's try that. Where is it? Under him down the lieutenant. The fighting machines. It's always about War of the Worlds stuff, this. So there we go. That's how we can create a simple ChatGPT-like client. So let me go back over to the real ChatGPT for a second. So they've got like a little saved area here where you can say, let me write. So for example, I was out for a meal last night, like a pre-Mother's Day meal with my mother. She works at Carnforth Station, and they have a clock there from the movie. Well, goodness, what was the movie? I can't remember what that movie was called. What is the name of the movie filmed at Carnforth Station? I'll remember it before we press it, probably. So it's going to generate that text. Brief encounter. It's actually writing it in the style of a poem, because I asked it before to write me a poem. I said, write me a poem about Carnforth Station clock in the style of Les Dawson, who's a comedian from the 70s and 80s, and it wrote a poem. And then I said, update the answer to the question of where is the clock, and speculate it, because the clock actually has gone missing. And there's a bit of beef about who owns the clock and who can wind the clock and all the rest of it. Alex also asked a question about acetylchlorine, chloroline. What does it do? It then wrote a poem about that as well, because it was in a poem mode. And then when I asked it what movie was filmed at Carnforth Station, Brief Encounter was its name, and it's written an actual poem in that style, which is just crazy. But yeah, you can basically go back to previous things. You can even get it to do things like draw diagrams. So I wanted it to create me a mermaid diagram. Let me see if this one will work. If I copy that code and I go back over to here, let's just create a new file. Test.markdown. Let's paste that in, and then let's see if we can get this to recognize that this is a mermaid diagram. So let's do that, and then let's type in mermaid. There we go. So we've got a little mermaid diagram. Mermaid is a way that you can create diagrams from text. So you can create all kinds of different types of diagram from text. You have to know what text to type in, obviously. But there you go, like Markov chains, text generation, stock price modeling, weather prediction. There are a couple of examples there. And ChatGPT can actually generate things like that. It's very, very clever. So yeah, you can do like a Chihuahua, a Chihuahua poem. Write me a poem about Chihuahuas using the first letter of the alphabet for each word. So you can see there. A, B, C, D, E, F, G, H, I, J, K. You can go back and re-edit it and say, and don't repeat a word, like so. Let's save and submit that, and it'll go off, and you'll see there the first letter of each word in the lines is unique and in alphabetical order. So that's pretty cool. So yeah, you can play with this. It's a really, really fun tool. I think you can actually register for ChatGPT for free. I've signed up for the Plus version, so you can get access to new features early, and you also get priority as well. So if you go onto ChatGPT, sometimes it says it's busy, the demand is too high. If you've signed up for the paid version, you can always get access to it. So that's a benefit of doing that. So yeah. You can even ask it questions like, there we go, 5 tips for making money with DIY robots. So focus on practical applications, find a niche, build a strong online presence, offer customization, partner with other businesses. So there you go. That's how we can do that, and this is our very crude version of that. Is that going to work? No, it doesn't recognize the word hello. If I just type the word say pointed out again. I love this. It's so much fun. Not very much useful yet because we've not really trained our model very accurately or very well, and we've only got a small corpus of text. But it works in the exact same way as ChatGPT's inner core, inner being does. There we go. That's the input from our Flask program that we created. Okay, let's get back to our keynote. So if you want to learn more about Python, MicroPython, building robots, and so on, you can check out kevsrobot.com/learn/. I've been building this out over the past couple of months, and there's so much stuff on there now. I have to redesign some of it because there is just so much stuff on there. If we go to kevsrobots.com and you can see now I've had to redesign the layout of this a little bit because there's just so much stuff. So we've got the how it works articles. I've literally just uploaded this to the Raspberry Pis behind me, and it takes a couple of minutes for Cloudflare to cache all these. So some of these images are not ideal for rendering on small web pages. There we go. So I need to do a few things with the CSS, I think, on here before I'm fully happy with this. But yeah, there we go. It's got the Twitter feed down the side, and we've got all the bits and pieces. So yeah, if you go to the how it works articles, for example, you can see all the different things that you can learn about. And there's also a glossary of terms as well. So every time I create a new how-to article, I'll add things that are new in there into the glossary as well. So I'm just building out the new glossary at the moment. But if there's a specific thing, so on here it's talking about, I don't know, cathodes, and then there's a thing about diodes in there because they have cathodes in them. They have anodes and cathodes. We think, what's an anode? You can jump to that, and it'll jump to the anode article there as well. So yeah, there we go. So if you want to check that out, there's some free courses on there you can take as well. And so we built the dashboard. We've done that one, Kevin. So if you've not already joined our Discord server, there's a growing community of people who are all fascinated and experts at robotics, Python, MicroPython, making stuff. So just go over to kevsrobots.com/discord if you've not already joined that. And if you want to help me grow my social media, I'd really appreciate a follow on these different platforms. So if you happen to use them, you can find me on TikTok. I'm at Kevin McAleer 6. On Instagram, I'm just at Kevin McAleer. And on Twitter, I'm at Kevin's Mac. I've just ticked over 5,000, is it 100 and something followers on Twitter. And I'm also on Mastodon at Kev's Mac at mastodon.social as well. So appreciate any kind of followers on there. And if you want to support the show, and there are a growing number of people who are doing this, you can do a super thanks if you're watching this and you want to sort of say thanks for the content of this. You can just hit the super thanks button there. If you're watching this live, you can do a super chat. And if you want to buy me an actual coffee, because sometimes I get a bit of a hoarse throat, you can buy me a physical coffee going to kevsrobots.com/coffee, and there's all the information there to do that. And finally, if you want to join the YouTube membership program, there's a little join button underneath the main window down that side, I think it is. It's next when you click subscribe, that's then replaced by the join button, I think. So that's for a price of a coffee a month as well. And then we've got our supporters. So now why has it done this? Honestly, let me just expand that a little bit. That's annoying. There we go. You didn't see that. So here are all the people who've supported the show. So we've got Marin, we've got Victor, we've got Roland, we've got Marcus, we've got Braun, we've got Carol. They've all bought coffee in the past month. Members, so Marlene joined us as a member. So we've also got John, we've got Tom, we've got Keith, we've got Shemi and Steve. And then YouTube members, we've got Carol. I think Carol joined quite recently. We've got Jose, we've got Dale, we have Skipper Banks, Jeff Ford, W. Peabody, Bill. We have Hans from Cheerlights, Michael, we've got Fraser, John Paul, and we have got Tom as well. Here we go. So let me go back to there. I think that's everything I've got for you today. So this is the point in the video. If you're watching this on replay, I'll say thank you so much for watching, and I shall see you next time.